So it's week 3 of advanced server-side scripting. So today we're going to dive back into Node. We're going to spend a lot of time playing around with NPM. We're going to play around with some Node packages and do a few different code samples, look at some different utilities, and you guys are going to have a second lab. Okay? I think I've marked, if you submitted lab 1, then I would have marked it by and large. The little rock, paper, scissors games are really well done. Most people's worked correctly. We may have a videographer who is here popping in and out. He was just trying to film some promotional videos for the computer studies area, so he'd filmed a couple of the other classes, and I said he was free to just pop in here, but he's already gone. I don't know if he's coming back. He won't disturb us. He'll just kind of do his thing quietly. Couple of things on here that I wanted to point out. Quick article. I'm not going to read through it. I'm just going to point out the link. I would strongly recommend having a look at this. This is a really kind of good high-level discussion about what types of applications are appropriate and what type of applications are not good fits for using this technology stack that we're working with in the class. Right? So he gives examples of some different business scenarios, different use cases. So some sort of easy to follow visuals as well. So that's the first link in the lesson 3 folder. I would highly recommend you maybe have a look at that on your own time. Okay. So I'm going to kind of skip through some of this stuff. We already talked about some of these things. We're going to do a little bit of this today. We'll more get into the MVC model really next week. Okay. For this week, we're only going to be doing one very kind of small part of this. But we'll start doing this. So I don't really need to talk about some of these things. So this week, we're going to just work with Node. We're going to get some applications launched and running in our browser using Node to generate our own local web server. Next week, we're going to add in this piece of Express. We'll spend a week or two playing around with Express. Then we're going to add on MongoDB. And then after reading week, we'll add security and we'll add Angular. So that's kind of where we're going. So this stuff is, we've already kind of gone over, so I'll skip past. The main thing we want to talk about today is NPM. NPM, which stands for Node Package Manager. Anybody ever used NPM? I guess maybe in Tom's class, a lot of you have used NPM. What is it? Like, what's the point of it?
So you don't have to go online to get the files and put files in the folder.
Okay, yeah, that's true. Why does NPM exist? What is it? And what's its purpose? Okay, it's a package manager. Yeah, that's in the name, right? Right in the name. NPM is Node Package Manager. But that doesn't tell us much about what it is. If we are going to explain it in everyday language to someone outside of this room, what Node Package Manager is and what the purpose of it, how would you explain it in non-technical terms?
You can create a kind of a module, I guess,
Yep.
JavaScript and make it available to anyone.
Okay, right. So basically, NPM is a library of pre-existing JavaScript code libraries or modules that we could add into our application, right? We did this when we worked with ASP.NET. We had a package manager. They called theirs NuGet Package Manager. What are the benefits to us? Why would we ever consider using packages that we download from NPM, or if we're doing .NET, download NuGet packages? What is that? Offers us several benefits.
Save time because somebody made some stuff functions which you probably just could use.
Okay, so it saves time. Yep.
Extend the application.
Yep, extend the functionality of our application. What about cost? What impact does using packages have on development costs? Yeah, well, generally the packages are free. They're open source. We're dealing with Node. So we're not paying for them. What about our development costs? Does it increase, reduce, or have no effect on development costs? Does. Well, how long would it take you? Well, what would be some examples of the kinds of functionality we might go out and seek out a third-party package rather than write the code ourselves. Why would we do, like, what would be an example of when finding a package might be an appropriate solution?
Some login maybe.
Okay, so we did it in ASP.NET, right? We used the ASP.NET identity package. How much time did that save us? How long would it take you to write all the functionality that was in that package? A long time. So what does that do to your development cost? Drops it, right? Rather than you spending the time to plan, test, debug something, we can just go and take something that's already planned, written, tested, debugged, plug it in. So it's going to reduce our development cost, right? So authentication would be one. What other kinds of things might we use somebody else's package for rather than writing it ourselves? What kinds of things do you think are common that lots of developers would want to do, so somebody's probably already built for us that we could just go and plug in?
Validation, shopping carts.
Okay, validation, shopping cart, yep. What other kinds of features? Security? Servers? Build tools? All of these things. Okay. So the package manager, NPM, is a command line tool that we can use to install, update, remove packages, to add, bring third-party libraries into our. So most Node sites are a mixture of some custom code combined with a whole bunch of modules that are downloaded and installed. Okay. So typically we have a few options for how we install packages. So typically we just run the command npm install and the name of some package. And then that package becomes available in that folder only, in that one project. So for example, let's say we want to do something, we find a package, we want to allow someone to sign in with their Google login. Well, we could go read the Google API docs and write it ourselves, or we could go and try and find a package that will allow someone to sign in with Google. The central repository for all of this is here, npmjs.com. So if there's any idea for a feature that we have, before we sit down and write the code, the first thing we should do is go to npm, right? So let's search for something like, so here's a Google Analytics package. So rather than set up and configure Google Analytics, all we would do is npm I, which is just short for install, or we could type the word install, and then the name of the package, which is connect-google-analytics. The packages can't have spaces in the names because those commands would then break in their command line. So if the package name has multiple words, they're just separated by hyphens. So to install this package, we would then be able to use it. All of these packages, the source code is available on GitHub. So when you run npm install, what it does is go to the GitHub repository and download a copy of that source code onto your machine. So then if you want to modify it, you could. Probably not a great idea, but if you want to customize one of the packages, well, you now have a local instance of it. And sometimes the documentation will be listed right here on npm's site. Other times you have to go to the repository. Well, their README doesn't tell us very much. You'd have to go into, here's the documentation and the samples. So we could go in and look at how to use it. So we can run npm install. We have a couple of other options that we're going to use. So this means install a package in this folder only. Okay. We also have this option, npm install -g. What this allows us to do is to install a package globally on our system. So we'll do this today because there are some development tools that are really useful for us, and we don't want to have to install them every week in a new folder. So if we install them globally, we can install them today, and then we can use them every week. We don't have to install them repeatedly. By default, a package will just install locally unless we specify it's global on our system, and then it gets installed in a different place on our machine. We'll look at those two different ones. Yep.
The packages in npm.js, how do you know they're any good?
Great question. Well, here's one we're going to use we're going to install in a bit, called Connect. So this will handle some of the HTTP server launching the server and handling requests and routing them. So we'll look at connect. Here are the things I always look for. First of all, do we have documentation? So there's a good clue. We've got all this there. It's well documented. So that's a sign they know what they're doing. Okay. The other things we can check, number one, how many releases are there? 226 releases. So this wasn't built yesterday, right? More importantly, the other clues are almost 250,000 downloads in the last 24 hours. Suggests it's reputable, right? So you can see the daily, weekly, monthly downloads. A package that's been downloaded 4 million times is probably one that works, okay? We can also, because all of these are published on GitHub, you can also log issues. So if we download this package and we find a bug, or we want to make a feature request, we can come here, we could open an issue on GitHub and post that for the developer. Hey, I tried doing this with your package and this is what's happening, or this would be a neat feature. Okay. Or you could even make a pull request where you contribute a new feature and send it to the developer and say, here, check out my feature. Maybe you want to add this to the next version of the package. The other ways we can tell, so what do you think these mean? We've got dependencies and we have dependents. What do you suppose those things mean? And this is still related to your question. Is that?
Dependencies that the library uses, the dependencies is inside of that library, and dependence that the other libraries depend this library to.
Right. So many NPM packages will depend on other NPM packages. So if we install Connect, it will automatically install all the dependencies. We don't have to install those 4. We're going to get them automatically. What this tells you is how many other packages on NPM you require Connect. So if you install any one of those 1,500, you're going to get Connect along with it. So again, that's a sign that it's a mature and reputable package. Okay. It's not a guarantee, but that's a sign. Okay. Now there's one humongous giant red warning with this. Okay. NPM packages offer a lot of benefits, and we've just talked about all of them. Speed, cost, functionality, performance, all these things are great. There's one potentially big gotcha. What's the risk in building an application and relying on a lot of these packages? Devin?
If someone decides to break their package or pull their package from the network, then unless you've got a backup or something, you gotta go.
Okay. Some of you may have seen this story. We actually talk about this? Maybe Scott, right? Which probably makes a little more sense now that we know what NPM is. Does anybody remember what happened in a nutshell? I mean, what you described is kind of exactly what happened. Do you remember the story?
Yeah, the guy had a particular name for it, I don't remember, and someone, I guess, had that name trademarked and got annoyed that this fellow was using that name. And so the developer just pulled the.
That's exactly what happened. So some developer who published hundreds of packages on NPM, he had one called Kik, K-I-K. It was 17 lines of JavaScript, and it was allowing you to write justify text. Okay? But there was another company who had the name Kik spelt the same way, and they trademarked the name. So they sent him an email and said, we've paid for the name Kik. You have to rename your package. And the developer said, forget it, I got the name. I'm not renaming the package. The company threatened to sue him. So he deleted the package from NPM along with the 273 other packages he published to NPM. The problem was this little 17-line package, and it may say in here, it was used by thousands of other packages, including this was the big one, Babel, which is a very popular JavaScript compiler, particularly it's used with TypeScript. So any site that used Babel used his little 17-line library. So by him removing it from NPM, he broke thousands and thousands of websites. So that's the danger, potentially, when you rely on these tools. It doesn't happen often, but it can happen. It's worth reading the story, actually. They actually describe some of the communication he had back and forth. And at the end of the day, he said, forget it, I'm taking all my stuff off of NPM. I don't want to put it up there and have this happen to me again. So he took all his code and he went home, basically.
Wasn't NPM going to give the repository name or something? Like that's what he was.
Yes, I think NPM.
Wasn't really fighting for him.
Well, they didn't support him.
Yeah.
No, that's,
Yeah, NPM. It does say somewhere in here.
is Kick still in business?
I don't know. So this was a year or two ago. Yeah, so NPM basically sided with the company. Yeah, so NPM said, I know you're frustrated, but there's nothing we can do. And he said for $30,000 he would change the name of his package. And they said, no, we've already paid for the trademark. We don't have to buy the name from you. We already bought the name, and you're using it illegally in effect. Okay. So that's kind of our one warning with it. We should be mindful of. Okay. Now, the other option we're going to use, and we're going to see what this is like in a minute. When we install a package, we can also add this option -save. We can install a package without this. Most of the time we install packages, we're going to want to use -save. What -save does, it actually will generate, if it doesn't exist already, or track in a particular configuration file, a list of all the packages we've installed in that one application and what version numbers. So this is really helpful if suddenly I'm working on a site and now I need help and I say, Brad, can you help me out on this site? If it's a Node site, the first thing Brad's going to want to do is look at that file and see all the packages, so he doesn't have to look through the code and try and figure out what packages have I installed. He can see a list of them all in one place, so he knows what is here. So let's play around with this a little bit, see how it works. So if you want to go into whatever folder you've been working with the last couple of weeks, you probably have a lesson 1 and a lesson 2 folder. Make a lesson 3 folder for today. It's going to be empty. And then open up your code editor of choice and just browse in and open up this folder. It'll be blank for now. We'll probably do 4 or 5 JavaScript files in here today. So I'll open up WebStorm. And I'll open up my lesson 3 folder I just built. So we've got this empty folder. So first we're going to install this NPM package called Connect. Connect, like I said, it will act as a web server for us and handle URL requests. So we'll try installing a few different ways. So I'll open a command prompt and I'll browse into my directory. So I'm in the same folder, both in my Windows file system as well as in my command prompt. I just use the CD to change directories. So I'm looking at the same folder from two different views. So let's go ahead and install Connect. The neat thing is also, if we then want to reinstall it, we don't have to remove it, it just will install over top. So I'll type npm install Connect, and we'll see what happens. I'm not going to install it globally. I'm not going to add anything else, just npm install Connect. If we want to install multiple packages at once, we just separate them with a space. I'll hit enter. All the slides that I'm kind of been toggling back and forth to, those are also all on Blackboard, so they contain all the commands we're going to run at the command line. So notice it installed Connect with a couple of dependencies. But we did get this error. So the file that was going to keep track of all of our packages is called package.json. It'll look something like this. So it's just a JSON document with the name of our application, a few other settings, and then a list of dependencies. So it'll track any packages we install. Now we can create this file ourselves, but NPM has a neat little command line utility that will auto-generate this file for us. So typically what we do is we're going to want to create that file. So the easy way to do this is run the command npm init. Same as initializing Git, we're initializing npm. And hit enter. And we get a message saying this will walk us through creating a package.json. We'll do it in a minute. We'll come back to it. We haven't done it yet, so we're going to do it. We'll see. So this is going to walk us through creating package.json. So it's saying, what's the name of your website? So by default, it defaults to the folder name, right? I can see in brackets, it says lesson 3. If I want to accept that as the value, I hit enter. If I want to name my application something else, I can just type it in here and hit enter. I'll just hit enter. Version, which starts with 1.0.0, which seems reasonable. I'll accept that, hit enter. Description, optional. I'll leave it out, hit enter. Entry point, we can leave it as index.js for now. I'll just hit enter. Testing, I can just pretty much hit enter all the way through. If we want to connect it to an existing Git repository, we can specify the Git repository right here. Any keywords, this is in the event we want to publish our project to NPM and let other people use it. They could search for keywords and find our module. Author, if you want, you can put in your name, doesn't matter. So I'm just hitting enter for everything. So then it previews the JSON file and says, here's what your package.json is going to look like. Do you like it? Yes or no? If you say no, you can start all over again and you can make changes. If you're happy with it, just hit enter. And now that utility has generated package.json for us in our folder. Right? If I open up my code editor, here it is. Now I can change the values right here in my code editor. I could have typed all this stuff. It was much easier to use npm init to build this for us. We'll tweak this a little bit later. So now we're going to install Connect. We already installed it. We're going to install it 2 more times. And Devin, the last time we'll use ---- save so we can see the difference between doing it with and without the ---- save option. Okay, everyone have their package.json? Hitting enter 10 times isn't too hard. So let's do npm install Connect again. Doesn't matter that we've already installed it. So now that we have package.json, it can handle installing all the other dependencies. Notice more stuff got installed this time than the first time. Also notice it did something in our file system. What change can we see here? Something's different now if you look at my main window. Yeah, it built a node modules folder, and there's connect, and there are all the things, dependencies and sub-dependencies of connect. So it's downloaded all of these. And these are just JS files. If we wanted to go in and they're open source, you want to change the way one of these works, you could go in, open up the JavaScript and change it. Right? Here's the JS file for connect. I don't recommend doing that. Now, if we look back at our package.json, nothing's changed here. So it's installed it, we can use it, but there's nothing in our site that tells us where this application is using that package. So Devin, I'm coming to your question. So typically if we install it, we're going to install it one more time. This time I'm going to add ---- save. Usually when we install, we're going to use the ---- save feature. And you'll see why in a minute. So run the command this way, npm install connect ---- save. What happens when you do that? So I'll hit enter to run this. So what was the difference between using ---- save and leaving it out? I'll let you answer your own question. Right. By adding ---- save, it will automatically track that package and list it in package.json. So we know our application is going to need connect, and we know what version number. This little character, anybody have an idea what that means? Why doesn't it just say version 3.5.0?
It doesn't automatically normally can update itself from 3.6 or 3.7, but that symbol prevents from making a major update, so it won't update itself to the version 4 without asking us.
Yeah. Okay. So now we know if someone else is going to look at this, we know they're going to know that connect is involved. So ---- save installs it and tracks the dependency in package.json. Doesn't track all the sub dependencies, just the one we actually install. Okay.
Why did we add that?
You may have to refresh your file. Are you using WebStorm or using a different editor?
Visual Studio
Code? You may have to refresh the view. Or close the file, just close package.json and reopen it. So most of the time we will use ---- save. Okay. We're going to come back to this version with the -g. We'll come back to that a little later. Later on, we're going to want to install a utility globally so that we can use it every week. It's not specific to any particular website. It's just a development tool that we'll want to use on all of our sites. So we'll come back and we'll do that in a bit. Okay, let's try creating a simple file here. We're actually going to create two files, and one file will load or call the other one. So let's create a new JavaScript file. We'll call it Say hello. I'm just going to follow along our little sample that we have here. We're going to create a variable. We'll use the let keyword. We could use var, but we want to use let. We want to use ES6. And we'll just assign it a value. And now we want to create an anonymous function that will print out that value. So we could do it this way. I'll write it this way, then we're going to make a change in a minute. Inside our function, just log out our variable, print out our variable. Now, instead of this being local, we want this function to be public so that it can be accessed by another file in our application. We want it to be a global or public function. When we create a variable with let, it's only visible in this file. No other files can see it. In a language like Java or C#, to make a property, a method, or an object available somewhere else, we use the keyword public. We don't have that kind of notion in JavaScript. There's no public word. Instead of making it local, we use this word. We export it. Export it is the same thing as making it public. So we're going to look at how this exports works. Then I'll change exports to lets once we run it, and you'll see the difference. So we're not going to call this file directly. We're going to call another JavaScript file, and that file will call this one. And this file will print a hello world message to our console. So once this file's done, make a second JavaScript file, name it call hello. So the first thing we want to do is link one file to the other. We did this already in week 1. How do we link one file to another? What function? It's like you used in PHP. Yeah, we use the require function. So we'll link to our other file. And notice what my code editor does. Notice when I type hello dot, it recognizes that function that's in my first file. As soon as I hit the dot, that function is available for me to call from here. So our second file will call our first file. So we're thinking about dividing up our code a little bit here. We haven't used the connect package yet. We'll use it in a minute. if we want to try this out, now I can run the command node and call hello. It should run this file, which links to the other file, and then I'm calling this function, which should print out a message to my console. Hopefully, we should get hello world printed in our console. So when I run the call page, it runs the say page, which prints a message. I'm going to make a change here. You don't need to change yours. I want to show you exactly what exports does, how this makes this function available in our other file. If I just use a local variable instead of making it public or exporting it, well, first of all, I'll try it again here. I'll run it again. First of all, when I try and execute this, it doesn't see that function anymore. It's not public outside of our first file. Even in my code editor, when I do this now, I'll delete this and try it again. When I hit dot, notice that function doesn't show up because it's no longer public. When I take away the exports keyword, that say hello function cannot be found by any other file. It only exists in my first file. Okay. So let is going to create a variable or a function that's only available within that file itself. Exports will make something visible to other parts of our application. And if we think about this for a minute, because we're going to be dividing our application up with this MVC structure, most things will have to be exported. Right? Our data has to get exported from the model to the controller. All of the functions in the controller have to be public so they can be called by some kind of server file. So we're going to be using that exports keyword often to make things visible across multiple JavaScript files. We don't want to write everything in one massive JS file. We want to divide our application up. So that's why our exports keyword is so important. That's the only way we can share data or functions across multiple JS files. So once I set it back to exports, oops. Right away, my code editor says, oh, that function's back. It's been exported, it's public, so I can see it. And I can use that function if I want to. So we installed this connect package. We can see it here, but we haven't used it yet. The reason why it was important to do this, a little example, is because we needed to see what that exports keyword means. Without exports, a lot of other stuff isn't really going to make much sense. And that example is here. I'm going to skip over this example. So for today, we've installed Connect. If we look back at the page we did back in week on the first day, let me just go back here, go to GitHub for a minute. Back on week one, we used the HTTP module, which is it's a core Node module. We didn't have to install it separately from NPM. It comes with Node. And we used it to generate this HTTP server so we could start up a server and see responses in the browser. We won't typically use this library. In fact, Connect is kind of a replacement for this because it has more features. And Express, which we're going to use after this week, sits on top of Connect. So we'll use Connect this week because it's simple. Next week and from here on, we won't use Connect anymore. We'll use Express, which still uses Connect under the hood, but the code's a little different. But the pattern we use with Connect will look familiar when we start with Express next week. And one of the neat things that it does for us is this. It does this dispatching. So it has the ability to take a URL, and then we can tell the server what is supposed to happen when we get a request at that URL. So it allows us to make simple friendly URLs, for example. But those URLs don't have to match a particular page name like they do normally. Normally, if we go to a request URL in the browser, that file name has to exist with the exact same name on the web server. This allows us to create kind of like virtual URLs and then direct those wherever we want. So we're going to look at how this works. So yeah, there was kind of the example we did previously where we used HTTP. So rather than using that, we're going to use a Connect version, which is a lot smaller. Our code to do the same thing will look like this. So we've already installed Connect, so we can link to it. This should probably be let. Then we'll create a new application using Connect, and then we can just call the listen method. That will start the server. So this is equivalent to what we did here. But why write that amount of code when we could use the package, the Connect package, so that we could write less code? So we'll try this example, and then we'll add on to it. Okay. So let's make a new file. We'll call it server.js. We'll do this one simple example, and then we'll take a break. And then we'll add on some more stuff to it. So the first thing we want to do is we need to link to the Express package. How would we do that? We've installed it. It's in Node modules. It's listed in package.json, but we want to tell this file to use Connect. So how do we link to an external file? Yeah, with require. So we'll use let. We'll create a Connect variable. So we were going to use that package that we've installed. So we're going to create a new object from the Connect library we've installed. Now we could type this, and if we were writing Java or C#, right, it would look like this instead. When we want to create a new object, we actually use the word new. This is correct. It's fine to use the word new here. It's implied in JavaScript, so we don't actually have to use that word new. And in most code samples we look at, we won't see it. So they are equivalent, but generally, why type something that doesn't do anything? If it works the same way without typing those extra characters, we'll leave them out. We'll start our server on port 3000. And we'll just log out a message. So when we launch this, we should get a message printing on the command line, and our command line should be frozen. The server should be active, so we can't type additional commands. And then we can try in our browser, we can try the URL localhost 3000 and see what happens. So once you've set this up, in your command prompt, try the command node space server. You don't need the extension. See if you get a message saying connect server running on port 3000. And then go to your browser and try localhost :3000 and see what happens. Okay. If you have a message that looks like this, you're doing it correctly. That's what should happen. So I'll try and launch mine. I'll try run node server. As my server's running and my command prompt is locked, right? It doesn't take me back to another command prompt in my file path for me to run more commands. So the server's active. And when I go to localhost 3000, not yet. We'll take a break in a minute. What's going on here?
Your browser is sending an HTTP request using the GET method.
Yep.
It's not getting any response.
Right. So we're sending a request. It's working. Like we're not getting, if I try localhost 4000, we're going to have a different response. What do you expect is going to happen if I try localhost 4000? It won't say cannot get. I'll give you a hint. Right? There is no server there. So we're not getting this error. So it knows we have a server on localhost 3000. It's not a 404 page not found error. The issue is, as Devin said, it can handle the request coming in, but we have yet to tell the server what is it supposed to do with the request, a GET request here. We haven't mapped it. That's really where this piece comes in. The dispatching. We know that URL request is coming in, but we don't yet know what's supposed to happen, how to handle that request. So what we're going to do, we're going to kind of take a break here. When we come back, we want to set up several different URL request paths, and we want to send different response based on the URL that comes in. So we'll add on, we can leave what's here. We have everything we have here we're going to need, but we need to add some URL handling here. So we'll do that when we come back. Okay, let's take a 10-minute break here. I'll leave this window up. I'm just going to stop my video.